Oh, okay, y'all. This is the a review for the FRQ portion of your Unit 3 test. Okay, so let's see what we have going on right here. Okay, a piecewise function, we have a quadratic if x is less than positive 2 and a linear if x is greater. So the question says, if we have these two values, is it continuous? So for differentiability, continuity, two things have to be met. So when we do this, when we replace a, b, and x in your top equation, we get something like this, -2. Okay, so f of 2 is defined, and f of 2 equals -2. Check. That's fantastic. And now the next thing we have to do is show that the limit from the left equals the limit from the right. Like that. Now, if this limit from the left and the right is the same as the y value here when x equals 2, then your function is going to be continuous. So let's do all the work so we can find the limit from the left and the limit from the right. And we see that the limit from the left is -2, just like it was for part 1, and the limit from the right is also -2. Okay, so that means that the limit as x approaches 2 is -2 also. Okay, so we can combine these two things, right, to answer our question. Therefore, is it continuous? Yes, it is. So we would write that f of x is continuous. Actually, let's go back. The question says, if a equals -3 and b equals 4, then, let's see, maybe not then. F of x is continuous at what point? At x equals 2. Because why? Because the limit as x goes to 2 of our function is equal to the y value of our function. Okay, so that's everything that we need for differentiability, for continuity, and we will answer the question in a complete sentence. It was asked, if a is this, will it be continuous? So if a is this, then f is continuous because the limit is the same as the y value. Okay, continuity, we need to have the function defined and the limit from the left equals the limit from the right. Okay, so part 2 says, well, is it differentiable? Okay, differentiable. So differentiability implies, number 1, that from part A, right, we already showed that this thing is continuous, right? That's part of it being differentiable, is that it has to be continuous. Okay, in my worst, sloppiest handwriting ever. From part A, our function is in fact continuous. And then the second part that we need to show is the limit of our derivative from the left is equal to the limit of our derivative from the right. Okay, so for differentiability, we're talking about the derivatives, so we need to show the limit of their derivatives are the same also. And if they are, it is differentiable, and if they not, it is not differentiable. So let's go back and let's take the derivative of our f of x up here. Okay, so if a is what, -3 again? So -3x squared plus 4x plus 2. The derivative would be -6x plus 4, just using the simple power rule. And for our bottom one, -3x plus 4, that linear, the derivative is just -3. Okay, so it might help to do this work up above, or you could show it in your box so that we can figure out what the limit as x approaches 2 from the left is, and the limit as x approaches 2 from the right. Okay, first things first, let's do the left. So from the left, our limit is -8 of our derivative, and from the right, our limit is -3. So we can come back here and then conclude that the limit from the left does not equal the limit from the right. Therefore, the limit at 2 does not exist. Okay, if the left does not equal the right, then we claim that the limit at 2 of our derivative does not exist. Okay, so then we put this all together in a nice complete sentence. If x is, or if a is -3 and b is 4, then f of x is not differentiable at x equals 2 because the limit does not exist. Okay, all those words. So there's not a whole lot of room in your box. I understand, kids in class, but hopefully that would all fit in there for you. So the last one says, what values of a and b will be both continuous and differentiable? Okay, so now we have to set up a system of equations and figure out what a and b makes this true. So we set up this system, right? This is from our function to begin with, replacing x with 2. We get a system 2a plus b equals -2. And from your derivative, we get 4a plus b equals 1a. So b equals -3. So now I'm going to substitute, right, the b into here, and then solve for a, and then I'll come back over here and find the b value. So doing that gives me an a value of +2 and a b value of -6. Okay, so then let's answer the question in a complete sentence. Okay, if a is equal to 2 and b is equal to -6, then f of x will be both continuous and differentiable at x equals 2. Okay, so the last thing we do with this AP Calculus stuff is answer the question in complete sentences at that point, right? We want it to be continuous and differentiable at x equals 2, so those are part of your answers. Okay, so there's a lot of kind of stuff there. Let's jump over and look at the other one. Okay, this one we have some tables and a graph, because in AP Calculus they want to give you all kinds of different ways of expressing your values. Okay, but this one just looks like it's some derivatives, so there's not a whole heck of a lot to do as long as you know how to take the derivative of different things using all the rules. So let's see what we have here. Okay, k is f of g of x. So this is once again a composition of functions. Write the equation for the tangent line for k at x equals 3. Okay, which means we have to take the derivative. Right, the tangent line, we need to find the y value, and we need to find the slope. The y value is pretty okay. We just have to plug in 3, right? Plug in 3 into x. What is f of g of 3? Okay, so we go to our table. The first thing we look at is g of 3. So when x is 3, g is 6. Perfect. So we replace that with 6. And now I'm looking for f of 6. So 6, my x value is 6 in my f column. I get a y value of 4. Okay, so I have a y value when x is 3, y is 4. Okay, so now we're going to go ahead and take the derivative so we can find the slope. And this is going to use the chain rule because that's what we do for compositions. So k prime is equal to f prime times g prime. Okay, so hopefully you have the chain rule memorized. So now we have to look and replace all of our x's with 3 and then go to our table. Okay, so g of 3, once again, g of 3 is 6, so that goes in here. Right, this becomes a 6. And g prime at 3 is 2. So I still have to find f prime at 6 now. F prime at 6 is going to be 5. So 5 times 2 equals 10. 5 times 2 equals 10. So then the equation of our tangent line, when we put it in point slope form, is y minus 4 that we calculated a second ago equals 10 times x minus 3. And that's the equation of your tangent line to the graph of k at x equals 3. Okay, a little bit of chain rule to start us off with. And then part B is a quotient, so now we're going to have to find the quotient rule. Okay, so h prime equals low times the derivative of the high minus the high times the derivative of the low over the low over the low function squared. So if we want to find h prime at 1, we have to go to our table and figure out what all of these values are. F of 1, g prime at 1 minus g of 1 times f prime at 1 over f of 1 quantity squared. Okay, so let's go to our table and figure out all of these values. Okay, so continuing on, now that we've written in all of our values, we just have to do some multiplication. Negative 48 minus 6 over 36. Looks like it's 54 over 36. And these are both divisible by 18. So if we divide 54 by 18, that's negative 3. And if we divide 36 by 18, that is 2. So h prime, the slope at positive 1, is going to be negative 3 over 2. Okay, a little bit of chain rule and quotient rule to start us off with. So hopefully you are familiar with your derivative rules. We will use them all the time. Okay, part C and D have this graph. So let's see what it asks us to do. The three-part definition of continuity. Okay, so number one, the first thing is that f of 0 exists. Or rather, yes, does it exist? Is there a y value when x is 0?
Yes. Oh. No.
No. So f of 0 is undefined. Therefore, we don't even have to do the other parts about the limit. Okay, so we can start saying right now that no, f is not continuous at x equals 0 because f of 0 is undefined. Okay, so the first part of our definition is that there's actually a y value there. And then the second part is that the limit exists. So if we were to have a y value, you could go find the limit from the left, which is negative 1, and the limit from the right equals negative 1. So the limit exists, but the y value does not. Okay, so part B says, or rather, maybe it should be D, I don't know. Here is our function, a multiplication. So what is the h prime? We're going to use the product rule, another one of our derivative rules, which says we take f prime times g plus f times g prime. Okay, that is the product rule for the multiplication of two different functions. So we're looking for f prime at negative 3 times g of negative 3 plus f of negative 3 times g prime of negative 3. Remember, the primes are the slopes. So we're going to have to look at the line and calculate the slopes of that line at each of these x values. Okay, so let's see what those are. The slope at negative 3 from our f graph is negative 1, right? It's going down from left to right. So the slope at negative 3 is negative 1. G of negative 3, that's just the y value. So what is the y value on the g graph?
4.
That's 4. Plus f of 3, that's just the y value on the f graph. So the y value at negative 3 is positive 2. And then g prime at negative 3 is the slope of the line at negative 3. So it looks like it's up 1 over... I think it's up 1 over 3. I think it's supposed to be going to this point right there. If you look to the left and the right, I would say it's 1/3. In fact, since I'm the key, it's going to be 1/3. So in essence, it's -4 plus 2 1/3, which turns out to be -1 2/3. So that is the slope of, let's see, what's the letter? H. H at -3. So H prime at -3 is -1 2/3. Or if you want to be fancy, we can write -5/3, and it would be correct also. Okay, so these FRQs talked about continuity, differentiability, and used a couple of our derivative rules in order to solve some questions.